Welcome to EDU World Space.
Okay, so this is the force diagram for the block A. So we consider the x direction is pointing along the surface, and the y direction is perpendicular to the surface. So let's assume that block A and B are at rest. Therefore, have the net force along the xy direction is equal to 0. So for block A, we have Fx is equal to Fsp plus Fa minus Wa sin theta is equal to 0. Therefore, Wa sin theta is equal to Fsp plus Fa. Wa here is the gravity of the block A, and Fsp here is the spring force from spring, and Fa here is the friction on block A. And then on the y direction, we have Fy is equal to Na minus Wa cosine theta is equal to 0. So we have Wa cosine theta is equal to Na. And we know friction at point A can be equal to the coefficient of the friction times the normal force at point A, which can be also equal to mu A Wa cosine theta, since Na is equal to Wa cosine theta. And this will give us Wa sin theta is equal to Fsp plus mu A Wa cosine theta. So we have Fsp plus mu A Wa cosine theta minus Wa sin theta is equal to 0. Let's say that this is the equation 1. So now let's take a look at the force diagram for the block B. So we have net force is equal to Fb minus Wb sin theta minus Fsp is equal to 0. So we have Wb sin theta is equal to Fb minus Fsp. Wb here is the gravity of block B, and Fb here is the friction on block B, and Fsp is the spring force. And then on the y direction, we have Nb minus Wb cosine theta is equal to 0. So we have Wb cosine theta is equal to Nb. And we know Nb here is a normal force at point B. And we know Fb can be equal to mu Bnb, which is equal to mu Bwb cosine theta. And this will give us Wb sin theta is equal to mu Bwb cosine theta minus Fsp. And this will give us mu Bwb cosine theta minus Fsp minus Wb sin theta is equal to 0. And let's say this equation here is equation 2. So now let's combine these two equations together. So we have Fsp plus mu A Wa cosine theta minus Wa sin theta plus mu Bwb cosine theta minus Fsp minus Wb sin theta. As you can tell, since it's Fsp minus Fsp, so these two terms here cancel out. If we do some arrangement here, eventually you have mu A Wa plus mu Bwb times cosine theta is equal to Wa plus Wb times sin theta. So we have sin theta over cosine theta is equal to mu A Wa plus mu Bwb over Wa plus Wb. So we know the coefficient of the static friction at point A is 0.15, and the coefficient of the static friction at point B is 0.25. And we know the gravity of the block A is 10 pounds, and the gravity of the block B is 6 pounds. So now we can plug in these values back into the equation. So we have tangent theta, which is sin theta over cosine theta, is equal to 0.15 times 10 to the I'm sorry, not 10 to, just 10 pound, and then plus 0.25 times 6 pound over 10 pound plus 6 pound, and this is equal to 3 over 16. Therefore, angle theta can be equal to inverse tangent 3 over 16, which is equal to 10.62 degree. So now we know that remember, Wa sin theta is equal to Fsp plus Fa. Therefore, this can be also equal to Fsp plus mu A Na, which is equal to Fsp plus mu A Wa cosine theta. So now let's determine the spring force. So I have Fsp is equal to Wa sin theta minus mu A Wa cosine theta, which is equal to Wa times sin theta minus mu A cosine theta. And we know the spring force can be equal to the spring constant times the changing distance, which is kx here. So I have kx is equal to Wa times sin theta minus mu A cosine theta. And this will give us x is equal to Wa times sin theta minus mu A cosine theta over k. So we know Wa is 10 pound, angle theta is 10.62 degree, and mu A is 0.15, and we know spring constant is given as 2 pound per feet. And if we do some calculation here, eventually we'll have the changing distance is equal to 0.1843 feet. Since it's positive, that means the spring is being stretched. And these are the answers for this question.